I'm Xianbo from the Chinese University of Hong Kong. In this talk, I will share our work on website defacement detection. This is a joint work with people from Sangfor Technologies and the Chinese University of Hong Kong. So what is website defacement? Here's an interesting example. In this screenshot of Google search result, can you notice anything strange? Look at the web page description. There are some unrelated and illicit keywords in our university's website. So what happened? If we dig into the source code of the web page, we can see that there are some malicious code snippets likely to be inserted by some hacker. And their purpose is quite clear, to promote their illicit products by hijacking search engine traffic. This is a typical case of what we call promotional defacement, and is what we try to detect in this work. Traditionally, these kind of hackings are a type of black hat search engine optimization, SEO, and well-known tricks like keyword stuffing and link farming have been around since the search engine was created. However, those classical tricks introduce massive modification, so they can be easily detected. People have proposed different approach for detection. One of the most popular approach is based on profile anomaly detection. Basically, to check whether a website contains some content that doesn't match its profile. For example, gambling content appears on a university webpage indicates something unusual. There are also other approaches like change monitoring and image-based detection, which are suitable under different scenarios. However, we observe that recent trend of defacement makes detection more challenging. This diagram shows modern defacement campaign based on the conspiring act of defacers and their customers. When someone wants to search for some illicit content, his search terms may trigger the block by search engines or other detection systems. So he will try his luck with obfuscated keywords instead, or we call it jargons. Defacers, on the other side, expecting this behavior of their customers, and then plant corresponding jargons into the hacked websites. Meanwhile, because of the uniqueness of the jargons, defacers only need to insert a minimum amount of content into the hacked website to evade detection, and can still have good chance to reach their customers. This new defacement technique introduced two key challenges. First, the detector needs to understand the obfuscated keywords, like the term highlighted in red on the defaced web page example on the right. Second, the detector needs to identify the tiny piece of defacement code from the whole web page, like the line highlighted in white. This is like searching a needle in a haystack. To tackle these challenges, we propose two key solutions. We design a jargon normalization algorithm to recover the obfuscated keywords, and we use tag-aware attention network to detect tiny insertions. Based on these two key ideas, we design and implement our cloud-based defacement monitoring system, DMOS. The user only needs to submit their domain to our service webpage. Then our system will actively monitor the web pages. For each web page, DMOS will first detect and recover jargons with jargon normalization component. Then the web page will be passed to the tag-aware machine learning component for classification. Now let's get into details of each part of our system. First, let's see what people usually do to create jargons. There are two types of jargons. One we call homophonic, in which some characters are replaced with characters in similar pronunciations. For example, the K replaced by C in the term Mark 6, as highlighted in blue. Another is homomorphic jargons, which means replacing characters in similar shapes, as the A to 4 example in red. Even worse, these two can be combined to create some mixed jargons. The result is easy for humans to understand, but will confuse machines. Note that we have mainly seen Chinese cases in the wild, possibly because there are a lot of Chinese characters in similar shapes or pronunciations, which gives more flexibility for obfuscation. This shows how the jargon normalization algorithm works. First, we feed sentences into a language model to detect non-fluent sentences. Then we generate candidates replacements for strange terms inside the sentence. After that, the replaced sentence goes through the language model again for fluency test. If it becomes fluent, that means we have found the correct recovery of the jargon. After jargon normalization, we will feed web pages into the machine learning classifier. Remember, the second key idea is to keep the tag information when doing this. So first, we will convert the HTML code into tag sentence pairs. Note that we treat tag attributes that can hold text as separate tags, like the alt attribute of image. Then we propose a tag-aware hierarchical attention network, THAN, to train the classifier. It first learns the tag sentence embeddings for each tag sentence pair. Then in the second layer, it learns to assign attentions to the tag sentence pairs and generates a single web page embedding vector for final classification. This visualizes the learned attentions. We can see that tags like title, meta, which are more essential to search engines, are automatically assigned with higher weights. Also, keywords related to gambling get more attention, while uninteresting keywords get lower weights. This diagram illustrates the effect of the overall pipeline of demos. Given a web page, our system will first identify and recover obfuscated terms inside the text content. Then it will assign attention weights to different text sentence pairs and outputs a single embedding for classification. We trained the system with about 500,000 labeled web pages. Then we conduct performance evaluation and ablation study. Our system outperforms existing solutions, boosts the precision from a level of 80% to over 90%. Note that some commercial web application firewall has relatively high precision, but also missed the majority of defaced pages. During the ablation study, we find that by enabling tag awareness, we can reduce the false alarm and thus relieve human efforts by 30%. The jargon normalization module alone can further reduce human efforts by over 40%. Together, demos can indeed achieve production-ready performance. We deploy demos to real customers and monitored over 38 million web pages for 5 months. The system has successfully detected over 500,000 defaced web pages in real life, and a significant portion of them belongs to influential websites, like government websites and university websites. We also did some comparison experiments to evaluate the performance of our system against some popular commercial URL checkers. We can see that demos increase both precision and recall largely. This table shows the top 8 jargons transformed from the Chinese term of Mark 6. You can see that this kind of techniques is quite common in defacement. And it's surprising to see how creative those defacers are, and they indeed obfuscate keywords with both characters in similar shapes and pronunciations. We count the frequency of infected HTML tags to see what kind of tags are more preferred by defacers. The high ranking of some tags like a, title, and meta are expected, as they are essential to search engine optimization. One surprising result is the marquee tag. If you look up a line, you can see that this is a non-standard HTML tag that can hold automatically scrolling text. We guess it can help defacers to evade detections by search engines or web application firewalls. Here are some other interesting findings. In a significant portion of defaced pages, defacement appears in less than 10 places. So this type of stealthy defacement are indeed common right now, overtaking old tricks like keyword stuffing. As we collected our dataset from various search engines, we also noticed that mobile search engines start to attract defacers' attentions, possibly because of weaker protection. Interestingly, In 2019, we noticed a spike of defacement in Chinese government websites. After some dig up, we find that it is a result of regulation change, which requires all government websites to migrate to a new official domain. So the old domains are left unattended. Finally, some conclusions. We have designed and deployed demos to monitor over 7,000 real websites and found over 11% of them have been defaced at least once. Although our design focuses on Chinese website defacement, we have also demonstrated that it's easy to extend to other languages with reasonable performance. We have released some English samples on our website. So please check our paper if you are interested in more details. And if you have any other questions, just drop us an email.